Hi guys, today's Leetcode daily is maximum count of positive integer and negative integer. So we are given an array which is sorted in non-decreasing order. Now this array will contain some positive numbers, some negative integers and some zero. So we have to find the count of positive integer, count of negative integer, and in this count whichever is maximum we have to return it. Now we'll see example for better understanding of this question. Like here, this is the nums array, and here 3 is the count of negative integers and 2 is the count of positive integers. So we'll return 3. Now we'll see brute force approach. So brute force approach is simple. We'll traverse in the array and find count of positive integers and negative integers. And after that, we'll see which is maximum of the both that we'll return. Now we'll see code to understand the implementation part. So we initialize n with the size of array, that is size of nums, and in the starting we take positive integer as 0 and count of negative integer as 0. Now we start traversing in the array. If nums of I is negative, then we'll increment negative count, and if nums of I is positive, then we'll increment the positive count. When this loop is completed, then at last negative will store the count of negative integers in nums, and positive will store the count of positive integers in nums. Will return max of both positive and negative. Now if we'll see time complexity, we are having only one loop which runs from for 0 to n, so the time complexity is O of n. And if we see space complexity, we are not taking any extra space, like we are not using array or vector, so space complexity is O of 1, which is constant. Can we do something better? So since in the question it is given that the array is sorted, so whenever sorted array is given, what comes in our mind? Like we always think like somehow we should apply binary search approach. So we'll see how we can apply binary search. First we'll understand what is lower bound and what is upper bound. So if any array is given and we want to find lower bound of a number, then lower bound, if that number is present in the array, then lower bound will return the index of its first occurrence, and if that number is not present, then lower bound will return the index of number which is just greater than it. For example, this is the given array and we want to find lower bound of 0. So since 0 is present, it will return 0's index, that is 3. And what upper bound will do, if we want to find upper bound of any number, and if that number, so upper bound will return a number index of number which is strictly greater than that number. For example, if we want to find upper bound of 0, then it will return index of number which is greater than this, that is it will return index of 1, that is 0 1 2 3 4, it will return 4. Now if we have an array which has some negative integer 0 and some positive integer and it is sorted, so how we can calculate count of negative numbers? It will be equal to lower bound of 0. See, lower bound of 0 here it gives 3, and since it is 0 based indexing, so count of negative integers is also 3, and count of positive integer is equal to total integer, that is n minus upper bound of 0. So here if we'll see, total integers are 7 and upper bound of 0 is index of 1, that is 0 1 2 3 4, that is 7 minus 4 equal to 3, so 3 positive integers are there. Now we know the count of negative integers, count of positive integers, so we can just return maximum of positive comma negative. Now we'll see code to get better understanding of the implementation part. In C++, we have built-in lower bound and upper bound functions, but I am building from scratch so that we can get more understanding, more learning. So first we'll see lower bound. In this function, our expectation is that if 0 is present, then it will give index of first occurrence of 0, and if 0 is not present, then it will give first occurrence of first positive number in the array. So first we took low as 0, high equal to n minus 1, and in answer variable we'll store the answer, that is lower bound. So While low is less than high, we'll find mid. Now we'll see if nums of mid is negative. So in no way between 0 to mid we can find any 0 or positive number. So this range is waste. So we'll do low equal to mid plus 1. But if nums of mid is either 0 or greater than 0, then this index can be one of our possible answer. So we'll store this index and we'll try further finding the smaller index. If we can find any 0 or positive number smaller than this index, that's why we'll do high equal to mid minus 1. When this loop will be over, then our answer variable will contain the correct index, which is the lower bound of 0. So we'll return the answer. Now we'll see implementation of upper bound. With this function, we have expectation that it will return the index of first positive integer in the array. So in the starting, we took low as 0 and high equal to n minus 1. In answer, we'll store the index, which is the upper bound. Now we started while low is less than equal to high, we'll find mid. And if nums of mid is negative or 0, then in no way between 0 to mid, we can find any positive number. So we just do low equal to mid plus 1. But if nums of mid is greater than 0, then since it is positive number, this can be one of our possible answer. So we'll do answer equal to mid and we'll try finding any other positive integer less than the index equal to mid. So we do high equal to mid minus 1. And at last, when this loop will be over, answer will contain the correct index, which will be the upper bound of 0. So we'll return answer. Now, as discussed earlier, negative count will be equal to lower bound of nums and positive count will be equal to n minus upper bound of nums, and we'll return maximum of negative comma positive. So if we see time complexity, then in this lower bound, we are using standard binary search with time complexity of we go of log n. This also same only we are using standard binary search with time complexity of log n. So overall time complexity is we go of log n. And we are not using any extra array or any other data structure. So space complexity is constant, that is we go of 1. If you understand this question, then please like, share and comment on this video and subscribe my channel for more such videos.